Hello guys and welcome to my channel Knowledge is Correction. So in this video we are going to discuss about a very interesting topic, that how you can run your electric vehicle using solar energy. So there are basically two ways that you can do it. The first is using an on-car solar PV system. So in this what you are doing is you are installing your solar panels on the top of your car and you are powering your EV battery through the solar panels. And the second option to charge your EV is that you can install a at-home rooftop solar PV system and then you can charge your car at your home using this rooftop solar PV system. So let's first discuss about this on-car solar PV system, okay? So for the calculation purpose, we are taking the example of TATA Nexon EV, and first we are going to see that is it feasible to put a solar panel on the top of the car and how much additional range can we get. So if you want to put a solar panel on the top of your car, there are two ways you can do it. The first way is that you can put the solar panels inside the roof, but this thing can only be done by the manufacturer of the car. And as we know that Tata is not providing any option like this, so this thing is not possible for us. What we can do is we can install the solar panels using some mountings like this. Okay, so we are going to focus on this method. So in this, what we have to do is we have to first calculate the area that we can install our solar panels on, right? What is the roof area of the car where we can install the solar panels? So in this way, we will begin our calculations. So first we are calculating that how much roof area we have where we can put our solar panels. Now if you see this top view of the Tata Nexon EV, and if you see the roof area, then this squared red rectangle what you are seeing is the amount of area which has to be calculated where we can put our solar panels, right? But if you want to know this area, it is almost impossible to search this area on net. You can't even find the slanted roof area of any car in the net. Okay, I tried to search it a lot, but it was very difficult for me to find it. And there was not any CAD model also from which I can easily get the area. The only information that we can make use of is the dimensions of Nexon EV, which we can get from the manual or from the net. So the length was 3993 mm, the breadth or the width was 1811 mm, and the height was 1606 mm. So this is the information we know, and we have to calculate this area to know that how much area do we have for our rooftop of the car. So in order to calculate this area, what I did was I thought of an idea and I took a graph paper and I actually photoshopped the top view of Nexon EV on this graph paper. Now see, if I zoom this area, okay, this area I'm zooming, so you can see it is something like this. So I have put the car in such a manner that the front end of the car is touching the y-axis and the side end of the car excluding the mirrors. Why excluding? Because if you check the width of the car, that is 1811 mm, this width is excluding the mirrors. So that's why I'm excluding the mirrors and then touching the end of the door end of the car, side end of the car. So I put the Nexon EV on a graph paper. Now we want to calculate this area, right? Where we can put our solar panels. So this is the roof area, the maximum possible roof area. I know that this is not a very accurate method of finding the area, but I think that this can give me a satisfactory results, right? So what I'm doing is, if you see this length, okay, from origin to the end of the car, so this is my length of the car, right? LC is the length of the car, and this is the length we want to find, right? The length of the panel, LP. So length of the car, I know length of the car is 3993 mm, right? And if you check on the graph paper how much unit it is, so it is approximately around 9.8 units, right? So this 3993 mm is equivalent to 9.8 units on the graph paper, right? So I can say that 1 unit will be equivalent to 3993 divided by 9.8, right? Now if I want to calculate the length of panels, it is approximately from 4 to 9.2. Okay, so this LP is 5.2 units. So LP is 5.2 units. So I want to calculate how much 5.2 units will be in mm. So 1 unit is this much, so 5.2 units will be 3993 divided by 9.8 times 5.2, right? So the length of the panel comes to be 2118.73 mm, or I can say 2.12 meter. So I can fit this much maximum length of the solar panels on the roof of my car, right? Now similarly, if you want to calculate the breadth of the car, we can see that the breadth is 1811 mm, right? So in this graph paper, if you see that this value is 1811 mm, right? And we want to find this, that is breadth of the solar panels, BS. Okay, now this 1811 mm corresponds to approximately 4.45 units, right? So 4.45 units corresponds to 1811 mm. So we can find 1 unit is equivalent to 1811 4.45 mm. So if you want to calculate the breadth of our solar panels, it is from, I can say, 0.55 to 3.85. So the BS value is approximately around 3.3 units. So 1 unit is equivalent to this. So 3.3 units will be equivalent to 1811 4.45 multiplied by 3.3, which comes to be 1342.988 mm, or I can say 1.342 meters, right? So this is nothing but the breadth of the panels that we can fit on our car. So we have found the length, we have found the breadth, right? So now to find this area, this shaded area, we just have to multiply those, right? So the area of the solar panels that I can fit, area of the panels that I can fit on my car is equals to 2.12 multiplied by 1.342, which comes to be 2.84 meter square. So this is the maximum area which I have on the roof of my car where I can fit my solar panels, right? Now again I am saying that this is not an exact method to find the roof area. If you guys know any other alternative for finding the area, then please write it on the comments. I will try that also. But according to me, it will give some satisfactory results, right? Okay, so now let's move ahead. Let's go to step 2. So after calculating the area, what we have to do is we have to search for an appropriate solar panel, right? Which we can fit on our car, which can give the maximum power output and have more efficiency. So first of all, you have to understand that there are two types of solar panels present in the market. The first is monocrystalline and the second is polycrystalline. If you want to know the difference between those two, so if you see a monocrystalline panel and a polycrystalline panel, if you compare in terms of efficiency, the efficiency of monocrystalline panels is always high. They have an efficiency of about 17 to 20%, whereas polycrystalline have an efficiency of about 13 to 16%. Design and looks is not too much important for us. The space requirement is important for us because monocrystalline panels occupies less rooftop space as compared to polycrystalline panels. And the performance is also better for the monocrystalline panels because they perform better even in low lights. And the price is expensive, but it's okay, we'll focus more on the performance and the space and the efficiency factor. So in order to get the maximum power output and high efficiency, we have to choose a monocrystalline panels. Okay. Now I have searched for a lots of sites where you can purchase the solar panels, and then I also compared what types of solar panels each of these sites are providing, and what is the maximum efficiency, what is the maximum power output that I can get. And then I came across this site vikramsolar.com, and I found the maximum power output which I can get from the area that we are having, right? So this vikramsolar.com is also an Indian site, and the product is also made in India. So let me just show you how you can go to this site and select the solar panels as per your requirement, right? Okay, so let's open this site. So this is how their page looks like. So in the top left corner, if you see, there are modules, right? So in this option, you can see monofacial and bifacial, two types of modules. Monofacial means that the solar cells are present only on one face of the panel, and bifacial means that the solar cells are present on both the face of the panel. So if you want to visualize, so in this picture, the solar cells are there on the top surface only, which is the sun facing surface. But if we also put the solar panels below the surface of these panels, that is the ground facing surface, then it is called a bifacial. Okay, bifacial module. So for our application, we have to choose monofacial module, right? Because the other side of the panel which we are going to fit will always be in the shadow. Now inside this monofacial module, you can see four types of modules that they are offering, right? So if you want, you can check all these modules. So I've already done that. And if you want the best efficiency and best power output and suitable for our application, then we have to go for Somera Series 6 half cell 156, Somera Series 6 156. Now understand what is this half cell. If you see in this Somera second option, you can see a full cell, okay, 72. Full cell 72 means that the solar panel consists of 72 complete full cells, right? And if you cut this 72 full cells in half, then you will get this half cell 144. So it consists of 72 cells cut in half, therefore total 144 cells, and hence it is called half cell because we are cutting them, right? In terms of power output, half cell can provide better power output than full cells because half cell has less power loss. So the best model which you can get from this site is Somera Series 6 half cell 156, this one. So this is the solar module which we can install on our car. And if you want to know the details of the solar module, you can download the specification sheet from here, right? So I have already done that. Let me show you. So this is the specification sheet which I was talking about. So we are installing this Somera Series 6 156 cells MBB, right? MBB is nothing but multi-bus bar, okay? So this is the technical data sheet. So let's first understand some important terms here, right? So this is the electrical data. So now here you can see the peak power P max that we can get is in the range of 475 to 505, right? Here also you can see the peak power output is in the range of 475 to 505, okay? Here you can see other specifications like maximum voltage, current, maximum current, okay? Now you have to understand one thing, that here I have highlighted also that this electrical data, all this data refers to STC. So STC is nothing but standard test conditions. And if you check this standard test conditions parameters, the air mass is 1.5, the solar irradiance is 1000 watt per meter square, and the temperature is taken constant at 25 degrees centigrade. But if you see in a real world, if you apply the solar panels on the roof of your car or anywhere, you will not get this 25 degrees centigrade all the time, right? So these properties which you can see here, electrical data, P max power, this is not a real world power output which you can get. So therefore, if you want to understand a more real life data or more real life parameters, therefore there is a concept of NOCT. NOCT is nothing but normal operating cell temperature. And here you can see the power ranges from 351 to 373.7, right? So on a real world, we can get this much amount of power from our solar panels. So for our calculation purpose, we are taking the mean value, that is 362.6. So if we fit this solar panels on the roof of our car, we can get 362.6 watt of power, okay? The other important specification which we have to see is the length, width and height, right? That if this solar panel can fit on the top of our car, right? So the length is 2.2 meters, breadth is 1.05 meters, and height actually doesn't matter for us, right? So 2.2 and 1.0, right? So let's again recall how much length and breadth were we having. So let's go back. So we were actually having a length of 2.12 and 1.3, right? So 2.12 and 1.3 we are having, and here it is 2.2. Okay, so we are having 2.1 approx, and here it is 2.2 and 1.04, and we are having 1.3. So the length is a little bit exceeding, but it's okay, we can manage that. It's not a problem, okay? Because if you see, what the length we have considered, we can also extend this length, okay, from in the back of the car, in the front of the car. So it's not actually a big factor to not install these panels, right? Okay. Moreover, the problem with having a smaller area solar panel is that their power output will be less, okay? And we want the highest maximum power output which we can get, so that we can increase the range to the maximum possible value, okay? Now one more important specification that I wanted to show you was, see here they are saying up to 21.02% efficiency, right? So now just for your knowledge, I want to tell you that how this efficiency is calculated. So this is just an additional knowledge that you can get. So if you see, the average annual radiation arriving at the top of earth from the sun is about 1361 watt per meter square. So it means that the average radiation coming from the sun on the top of the earth, not in the earth, on the top of the earth, the radiation that are coming from the sun is 1361 watt per meter square. And the sun rays are attenuated as they pass through the atmosphere, leaving a maximum normal surface irradiance of approximately 1000 watt per meter square. Attenuated is nothing but like when the sun rays pass through the earth atmosphere, they get absorbed by the particles present in the atmosphere, that is nothing but attenuated. So when the sun rays are passing through the earth atmosphere, they get a little bit absorbed by the particles present on the earth's atmosphere, and this irradiance value comes down to 1000 watt per meter square from 1361 watt per meter square. So if you see on all the surface of the earth where the solar panels are present, or anywhere on the surface of the earth, we are getting 1000 watt per meter square of surface irradiance from the sun, right? So in an ideal case, without any losses, we should be able to get 1000 watt of power from 1 meter square of area. 1000 watt per meter square means what? 1 meter square will get 1000 watt of power from the sun on any surface area on the earth, right? Now the solar panel which you have selected, let's again write down the properties of that solar panels. So those were monocrystalline panels. The length was 2.288 meters, the width was 1.050 meters. So the area is coming to be length into breadth 2.4 meters square, and the power output was 362.6 watts, right? So we have an area of 2.4 meters and power output of 362.6 watt, right? So 2.4 meter square area is providing a power output of 362.6 watt. So 1 meter square will provide 362.6 divided by 2, that is 151.08 watt. So if you want to calculate our solar panels, we have seen that in an ideal case, the power output should be 1000 watts from 1 meter square of area. And how much we are getting from 1 meter square of area? 151.0 watts. So our power output is 151.08 divided by 1000. But understand why I am not dividing it by 1000. Why I am dividing it by 800? Because if you see the properties of that solar panel, so here we are taking electrical parameters at NOCT, right? So at NOCT, if you see, the NOCT irradiance is 800 watt per meter square. In the if you take the values in the STC condition, standard temperature condition, the irradiance was 1000 watt per meter square. Then we have to divide it by 1000 if you take this value, okay, 490. But you are taking 362.6, so we have to divide it by 800 watt per meter square because it is at NOCT. So therefore, while calculating the efficiency, I am dividing the power output by 800, right? So the efficiency is coming to be around 0.1888 or 18.88%. So the solar panels which we have chosen can convert the sunlight radiation to the power output with an efficiency of 18.88%, right? And it was a monocrystalline panel, okay? And if you check, we have mentioned in this photo also that the efficiency of monocrystalline panel ranges from 17 to 20%, right? And we are getting 18.88%. So that is very good, okay? Now let's move ahead. Now our step is to calculate how much range you can add by installing a solar system on the roof of your Nexon EV, right? So now let's suppose that we have attached this 362.6 watt or 0.362 kilowatt solar panels to our Nexon EV. 0.362 is the power output of the panels which you are getting, right? Now on an average, I'm considering that 4 hours of sunshine is available on your area, okay? It may vary according to your location. Some might even get 5, some might even get 3, right? So on an average, I'm considering 4 hours. So we can get 0.362 kilowatt times 4 hours. That is 1.45 kilowatt hour of electricity in one day. 0.362 is the power output of our solar module, and 4 hours is the duration when sunlight is present. So we can get 0.362 kilowatt times 4 hours, that is 1.45 kilowatt hour of electricity in one day. 0.362 kilowatt is the power output of the solar module, and we can get 4 hours of sunlight in a day. So the electricity generated in one day by the solar panels which are fitting on the top of Nexon EV is around 1.45 kilowatt hour, okay? Now the battery capacity of Nexon EV is 30.2 kilowatt hour, and I am taking the real world range to be 250 kilometers. Now some might get a range less than 250 kilometers and some might get even more than 250 kilometers. It all depends upon how efficient you are driving and what are the driving conditions, right? So on an average, I am taking it to be 250 kilometers. So 30.2 kilowatt hour of battery is providing me a range of 250 kilometers. So 1 kilowatt hour of electricity will give me 250 divided by 30.2, that is 8.28 kilometers of range. Now how much electricity am I producing with the help of my solar panels which I have installed on the top of our car? 1.45 kilowatt hour, right? So 1 kilowatt hour is providing me a range of 8.28. So 1.45 kilowatt hour of solar module will provide me 1.45 times 8.28, that is 12 kilometers of range. So theoretically, you can add 12 kilometers of range per day to your Nexon EV by installing solar panels on the roof. Now understand why I'm saying this word theoretically, okay? Because the real world scenario is going to be different, okay? If you check the real world scenario, the power output of the solar system will never be constant, and the solar irradiance will vary with respect to time and place, okay? So let me explain you this in a bit deep manner. So if you go back to the specifications of the solar module which you have selected, and if you see is typical IV curve here, okay? So IV curve is nothing but in the y-axis you are getting current, and in the x-axis you are getting voltage, okay? So in this IV curve there is one more curve known as power and voltage curve. So in this figure there are actually two graphs present. One is current versus voltage and one is power versus voltage. So these graphs which you can see, these ones are the current versus voltage, and these ones are the power versus voltage graph, okay? So we have to focus on this power versus voltage graph. Now if you see this different color lines, okay, green color, black color, blue color, oh, this is dark blue color, light blue color, black color, red color. So here you can see the value of the solar irradiance. So if you are getting 1000 watt per meter square, then you have to follow this red line, okay? And this is the amount of power which you are getting. So if the solar irradiance is a little bit less, that is 800 watt per meter square, then the power output will be less. If it is even less, that is 600 watt per meter square, the power output will be even less. And you can see that we are not getting a constant power output. So suppose I am taking a irradiance of 600 watt per meter square, then we have to follow this blue line, okay? So see, y-axis is the power output. So the power output is increasing. It reaches a peak value of approximately around 300 watt, and then it decreases. So the power output will never be constant. So the power output which you have taken here on our calculation 362.6 will never be constant. First of all, it will depend upon how much irradiance is available on your area, and then again it might increase or decrease, okay, and it will reach a peak value, but it will not remain constant. So that's why I've said that if you check a real world scenario, then the power output of the solar system will never be constant, and the solar irradiance will vary with respect to time and your location. And also the panels can be installed in such a way that it can capture maximum sunlight because the car will be in motion. Now suppose you're installing this solar panels at your home on the rooftop, then you can set a perfect angle of the solar panels, that is a perfect inclination, and the solar panels will always face towards the sun, right? So that we can capture maximum amount of sunlight. But it is not possible to do so while when you are fitting your solar panels on the top of your car, right? Because the car will always be in motion. So you can't preset a particular angle of the inclination of the solar panels on which the amount of sunlight will always be maximum, right? Also, any building or tree shade will decrease the power output of your solar panels exponentially, right? Because that part of the solar panel is not receiving sunlight, so it will diminish your power output. Also, we can't directly connect our solar module to the EV battery. A BOS, that is balance of system, has to be involved, which will cause efficiency loss. So the power output from the solar module to the battery will decrease. Now this BOS balance of system is nothing but it consists of all the other instruments that we use while installing our solar module, like the inverter, the wires, the connections, all those things. Okay, so that will also have some efficiency loss, and the power output of the module will decrease when it reaches the battery, right? Because of this losses. Also, installing solar panels will increase the overall weight of the car, which will put more load on the EV battery, and ultimately the range will reduce. Okay, so if you see the specifications of the solar panel which we are installing, okay, let's go back. You can see that the weight of the solar module equal to 26.9, so almost 27 kg you are adding to your car. Now this 27 kg, this additional load is taken up by the EV battery, which is going to reduce your range. Also, if we install solar panels separately on the roof, it is going to mess up the aerodynamics of the car, which is ultimately going to reduce the range. So these are some real world scenario parameters which we can't quantify and include in our calculations. But according to me, if you take all these parameters into consideration, then the theoretical range of 12 kilometers which we are getting, I think we will not be able to get even half of this. So according to me, in a real world case, you can't get more than 5 to 6 kilometers of range on your Nexon EV if you install the solar panels on the roof of your car. And that is the reason why these car manufacturers are not doing so. Also, the solar module alone costs around 20,000 rupees, excluding the BOS, that is balance of systems. So at the end, I just want to add that if someone is really interested in doing this kind of project, so they can try installing this solar panel on the roof of their EV or Nexon EV or whatever EV they are having. So if you want, you can perform your calculations like I've shown, and you can actually do this in practical, and you can check then how much range you are getting. And if you are satisfied with this additional 5 to 6 kilometers of range on your Nexon EV, so you can also try installing this solar panels. It will cost you around 25,000. Plus you have to also put some work in the connections, right? So you can't directly just connect the solar panels to the EV battery. So if you want me to make a video on how to do the connection, you can also comment on the comment section. So I think this is enough for this video, guys. Also in the next video, I am going to discuss about at-home rooftop solar PV system, because according to me, and it is my opinion, right? Your opinion might vary. According to me, getting only 5 to 6 kilometers of range maximum is not very beneficial to me, because I am spending so much amount of money and so much amount of time in doing this, in making this system, and I am getting only 5 kilometers of range per day. Also, most of the time my car will be parked in a garage or where the sunlight is not coming, so I might not be able to generate any power output. So I think this on car solar PV system is not a good idea according to me. You might contradict with me, but it's okay. So what is the more economical way that you can run your electric vehicle using solar energy? That is at home rooftop solar PV system. So in my next video, let me just give me 1 second. So in my next video, I am going to show you rooftop solar system calculations, and I am going to tell you that how you can reduce your home electricity bill to zero, as well as make the running cost of your EV, that is electric vehicle, zero. And we are going to do some calculations to find out what is the power of solar PV system that you will require, how much roof area or rooftop area you will need to install the required solar PV system to meet your demands. Also, we are going to calculate the rooftop solar panel installation cost, and I am going to show you an actual quotation also. And also we are going to see what will be the per month savings, and then we will also calculate what will be the ROI, that is return on investment. Okay, so if you are interested and curious to know about this all these things, then you can check out my next video. And thank you guys for watching this video. If you have learned something, please like this video and subscribe to my channel. Thank you very much.